Hello everyone and welcome back to another video. Today I'm going to be sharing my solution to Codeforces problem Moamen and K subarrays. So I hope that you've read the problem statement first before seeing this video, but basically the problem says that we have an array of n integers and an integer k, and we're asked, is it possible to sort this array by dividing it into k subarrays and then rearranging those k subarrays? So for example, here we have this subarray 6, 3, 4, 2 and 1. I could create the following subarrays: 3, 4, 2, 1 and 6. So now I have the following 4 subarrays. I can just rearrange them like so. And as you can see, in that case it was possible to sort the array by dividing into 4 subarrays and rearranging them in this way. So this problem solution depends on one key observation. Once you find that observation, the problem is going to be easy to solve. So did you notice something? Did you notice that in order for our final array to be sorted, the actual subarrays that make it also need to be sorted? And that is basically the key observation. As you can see, the subarray 3 and 4 is sorted. The subarray 2 is sorted. Subarray 1 is sorted. Subarray 6 is also sorted. So all we have to do is check how many sorted subarrays are possible in this subarray. And if that number is less than or equal to k, then we should output yes. If it is not, then we should output no. So a simple algorithm for this is to first of all to get that input array and then sort it like so. After we sort that array, we keep track of all of the indexes of our elements, the previous indexes that were here. So 6 had an index of 0, 6 had an index of 0, 3 had an index of 1, 4 had an index of 2, 2 had an index of 3, and 1 had an index of 4, as you can see. Now all we gotta do is just iterate over the sorted subarray and check if the elements that is right after it, for example element 1, we're iterating over 1. Well, the element that is right after it is 2. Okay, now what is the index of 2 in our original array? The index of 2 in our original array is 3, and the index of 1 is 4. As you can see, 2 is actually before 4 and not after it, which means that is not a non-decreasing order. That is a decreasing order, which is not sorted, which means that 2 cannot join the subarray of 1. So now as you can see, now we have our first subarray. Then we go ahead. 2. The element that is right after 2 is 3. What is the index of 3? It's 1. Okay. And what is the index of 2? Well, it's 3. They are not right after each other. There is a gap between them. And so 3 cannot also join the subarray of 2. Then we go ahead and check. 3. Well, what is the index of 3? The index of 3 is 1. Well, what is the index of 4? The index of 4 is 2. As you can see, the index is 4 is right after 2, which means they are after each other, which means that the order of this subarray is non-decreasing, which means that 4 can join 3 in its subarray. Then we check 4. Well, what is the element that is right after 4? Well, it's 6. Well, what is the index of 6? The index of 6 is 0. What is the index of 4? The index of 4 is 2. As you can see, 6 is not right after 4, so it cannot join this subarray, so it's going to have to create its own subarray. As you can see, now we have 4 subarrays, and the k that was given us to the input was 4, which means that we could output yes. That is the basic idea of the algorithm, and I have it over here. So over here we have our input array, and then we have n and k, and then we have this parts variable that keeps track of how many subarrays we have. Then we have that map of integers. That map actually keeps track of the indexes of the original array. So over here, as you can see, we're taking the array and we're keeping track of the index of the elements. Then we sort the input array. After that, we are iterating over each element, checking if the index of the element that is right after me, so for example, if the index of element 4 is actually right after the index of the element 3. If it is not, then we could just increase our subarrays. If it is, then we could leave our subarrays alone. Now this if statement is really important. You'll notice that the last and biggest element of the array is always going to have its own subarray. So that is why we actually need to handle that case. If I equals n minus 1, which is basically the biggest element that our array can have, then we just increase the number of subarrays. And if parts more than or equal k, then cout yes and then cout no. Now we can just try submitting our solution on Codeforces and judge it. So if we submit our solution, let's see if it's accepted or not. As you can see, we got an accepted answer. So this was today's video. Hope you enjoyed. My answer isn't necessarily the best, but it definitely worked.